Alright, alcohols can be converted into alkyl halides. The first and the very usual method is use of halogen acids such as HCl, HBr, hydrogen iodide. In this reaction, a water molecule is formed as a side product. For example, ethanol, when treated with HCl, forms ethyl chloride. Similarly, when 2-propanol is treated with HCl, it forms 2-propyl chloride. When tertiary butanol is treated with HCl, the reaction is fastest and it forms tertiary butyl chloride. Similarly, in case of bromides and iodide, alcohol can be treated with hydrogen bromide in the presence of concentrated sulfuric acid to give ethyl bromide, and in case of hydrogen iodide, ethyl iodide as the products. Now the question arises, what is the mechanism of this reaction? Actually, the mechanism is quite simple. Since the reaction is occurring in the presence of acid, then it is normal for a alcohol molecule to get protonated and OH group, that is hydroxyl group, is converted into OH2 group, which has oxygen has positive charge. Now this group is a good leaving group now. It is a good leaving group. As a result, it departs to form a carbocation. This carbocation is further attacked by the halogen anion to form our final product, which is alkyl halide. Since carbocation is formed as a intermediate, so reaction rate will depend upon the stability of carbocation. Therefore, the stable carbocation is CH3 plus, but primary carbocation is more stable. Then further, secondary carbocation is even greater stable, and at the end tertiary carbocation is the most stable of all these. Since this methyl carbocation can be obtained from methanol, this can be obtained from ethanol, this can be obtained from propanol, and this carbocation, tertiary butyl carbocation, can be obtained from tertiary butyl alcohol, that is primary. No, this is not, this is primary, this is secondary, this is tertiary. Now the stability increases here, stability of carbocation increases Therefore, rate of reaction also increases. Thus, the order is tertiary followed by secondary followed by primary alcohols in this particular reaction. Second method to convert alcohols into alkyl halides is the use of phosphorus compounds and SOCl2, even sometimes SOBr2 is also used. So what happens is this: when we treat alcohols with PCl5, this hydroxyl group is replaced by chlorine atom. That means the product becomes CH3CH2Cl, and also a side product is also obtained, which is POCl3. This reaction works well with primary and secondary and even tertiary alcohols. It is simply the OH group which is replaced by Cl. So cyclohexanol gives you chlorocyclohexane. Similar can be achieved by using SOCl2 in the presence of base like pyridine, in which OH group is again replaced by chlorine. So chlorocyclopentane is obtained with the release of sulfur dioxide and HCl gas. Similarly, in case of bromides, PBr3 can be used, which again results in the formation of bromocyclohexane. That is, now we are using PBr3, therefore OH is replaced by bromine. Similarly, if we use PCl3, this will give you chlorocyclohexane, and when we use the trihalide derivatives of phosphorus, then phosphoric acid is obtained as a side product, H3PO3. So again, these are the two methods by which alkyl halides can be obtained from alcohols. Thank you.